Continuing on with your workbook questions, we have number 7. A support cable is anchored 15 meters above the base of a pole and is attached to the pole 10 meters above the ground. Determine the length of the cable to the nearest tenth of a meter. So let's draw a picture first. We have our X and our Y and our origin. And we have a pole that is 15 meters from the base and 10 meters above ground. So we're going to have a point P at 15, 10. Attaching our cable, which is our terminal arm, we're creating a new right triangle with side lengths of 15 and 10. Here's our terminal angle. We want to find out our R, our length of the cable. So let's use Pythagorean. R squared equals X squared plus Y squared. R squared equals our X is 15 and our Y is 10. 15 squared is 225. 10 squared is 100, leaving us with 325. Square rooting, we get a value of R equaling square root 320. Solving that, we find R equals 18.0277, which is approximately 18.0 meters. That is our final answer to a tenth of a meter. Part B says, to the nearest degree, what angle does the cable make with the ground? So here we're looking for our theta value. Let's use a trigonometric ratio, and more specifically tan theta, which is 10 over 15, our y over our x, right? So solving for theta, we get tan inverse of 10 over 15, which equals 33.6900, which is approximately 34 degrees. Number 8. Determine the distance of each point from the origin. So we're given a point and we want to find our distance from the origin. This distance here, which we generally label as R. So we want to use our Pythagorean for both of these questions. A, we have R squared equals our 4 squared plus our 6 squared. R squared equals 16 plus 36. R squared equals 52. Square rooting both sides, we get R equals square root 52. For point B, we have R squared equals 7 squared plus 3 squared, which is 49 plus 9. R squared equals 58. Square rooting both sides, we get R equals root 58. Part B asks, each point in part A is on the terminal arm of an angle theta in standard position. For each angle, determine cos, sine, and tan of theta and the measure of theta to the nearest degree. So we know we're looking for our sine theta, our cosine theta, and our tangent theta. And remember the ratios for sine, cos, and tan are sine y over r, cos x over r, and tan y over x. Plugging in for our values, we get 6 over root 52 from A, and then 4 over root 52, and 6 over 4, which can be reduced to 3 over 2. Now to find theta, we use one of our trigonometric ratios, and let's use tan theta equals 3 over root 2. Solving for theta, tan inverse of 3 over 2, which equals 56.3099, or approximately 56 degrees. For B, sine theta, cos theta, and tan theta. We get our y over r again, and our x over r, and then our y over our x, which equals 3 over root 58 from part A, and then 7 over root 58, and 3 over 7. Again, solving for theta, let's try using tan, which equals 3 over 7. Theta then equals tan inverse 3 over 7, which comes out to 23.1985, or theta is approximately 23 degrees. Number 10. Each angle theta is in standard position in quadrant 1. A. We have cos theta equals 5 over 13. What are sine theta and tan theta? We know that our cos theta equals our x over our r, hence x equals 5 and r equals 13. But to solve for our sine theta and tan theta ratios, we need a value of y as well. So we will use Pythagorean here. And we get r squared equals x squared plus y squared. R is 13, x is 5, and we're solving for y. We get y squared equals 169 minus 25, which equals 144. Square rooting both sides, we find that y equals 12 here. Now plugging into our ratios for sine theta and tan theta, we find sine theta equals y over r, which is our 12 over our 13, and tan theta equals y over x, which is our 12 over our 5. For B, we have sine of theta equaling to y over r, hence our y equals our 2 and our r equals our root 5. Again, we need to solve and find x. We'll use Pythagorean. R squared equals x squared plus y squared, which is root 5 squared, and x squared and y squared is 2. We'll leave with 5 equals x squared plus 4, hence x squared equals 1. And square rooting, we find that x equals 1. So plugging into our cos theta and our tan theta, we find cos theta equals x over r, and tan theta equals y over x. Plugging in, we get 1 over root 5, and then 2 over 1, which just equals 2. And theta equals our y over our x, and hence our y equals 3, and our x equals root 7. We need to find r. We'll use Pythagorean, hence r squared equals x squared plus y squared. R squared equals root 7 squared plus 3 squared. R squared equals 7 plus 9. R squared equals 16. Square rooting both sides, we find that r equals 4. Hence, for our sine theta and our cos theta, which will equal our y over our r and our x over our r, we find sine theta equals 3 over 4, and cos theta equals root 7 over 4. Now number 15. A point P is on the terminal arm of an angle in standard position in quadrant 1. The distance r between P and the origin is given. Determine the possible coordinates for P. So that's asking what P of x, y are. And we're only given the terminal arm length 2p. So we're only given r, but we do need to find our values for y and our values for x. And we also do not know the terminal angle point. But from Pythagorean, we know that our r squared equals our x squared plus our y squared. Plugging in for r, we have root 29 squared equals x squared plus y squared, leaving us with 29 equaling x squared plus y squared. We need to find two numbers whose squares equal 29. I can think of the fact that 2 squared equals 4 and 5 squared equals 25, where 4 plus 25 equals 29. This is the exact combination we're looking for. Hence, I can deduce that we can either have a point of 2, 5, or a point of 5, 2. At part B, very similar, we can deduce that from our Pythagorean theorem, r squared equals x squared plus y squared, plugging in for r for root 74 squared equals x squared plus y squared, leaving us with the fact that 74 equals x squared plus y squared, and hence we need to find two numbers whose squares equal sum of 74. I can deduce that since the square of 5 is 25 and the square of 7 is 49, where 25 plus 49 equals 74. Hence, we find that we will have either a point of 5, 7 or 7, 5.